So we've already talked about parallel and perpendicular lines and specifically looked at the slopes of those lines and how those equations relate to one another. In today's lesson, we're going to be looking at parallel and perpendicular lines, but how they relate to the coordinate system, so graphing on a coordinate grid, and looking at the slopes of their sides and determining what side or what type of a polygon is being graphed in the coordinate grid. So just a quick review for parallel and perpendicular lines. Parallel lines, the slopes of each line are the same. So if we have two equations of lines, the slope, the value of m, is going to be the same if the lines are parallel. And parallel lines means that the lines do not ever cross, they never intersect. Perpendicular lines, the slopes of each of those lines are negative reciprocals of each other. So if the slope of one line is 3/5, so that's the slope of our first line, the slope of our second line, in order for it to be perpendicular, it's going to be a negative, so the opposite, negative, and the reciprocal of 3/5. So a negative 5/3 would be the perpendicular slope that we would be looking for. In perpendicular lines, when they intersect, they form right angles. Just a quick review for four-sided polygons, as we're going to be using those today. First, we have the rectangle. So a rectangle has right angles, has perpendicular sides. Then we have the square, 4 right angles, and then also 4 equal sides. For a parallelogram, opposite sides are parallel. So looking at this parallelogram here, these two sets of lines are parallel, and these two sets of lines are parallel. We also have a trapezoid. They have exactly one set of parallel lines and no right angles. And then lastly, we have a rhombus. A rhombus is similar to a parallelogram, but the side lengths are all equal for a rhombus. So 4 equal sides for a rhombus. So just to get into the starting for this lesson, if we want to graph the 4 points, we can determine what polygon is being graphed. So if we have -2, 1, so -2 up 1, here's our first coordinate. -2, +5, so -2 up to 5 is our second coordinate. 3, 1, so to the right, 3 up 1, and to the right, 3 up 5. So looking at this shape, it looks like a square, but to make sure that it is, we want to count that the lengths are the same. So from here to here, we have 1, 2, 3, 4. From here to here, we have 1, 2, 3, 4, 5. So it's not a square. This one is actually a rectangle. So this one forms a rectangle. Let's look at another example. If we plot these 4 points, what four-sided polygon is going to be graphed? So -5, 0, -5, 0, -4, 3, 2, 2, 3, so to the right 2, up 3, and to the right 1, and then at 0. So if we were to connect the lines for this polygon, think about what shape is graphed for this one. I see that this line here and this line here are parallel, and then this line here and this line here are also parallel. There's no right angles, and the sides aren't all the same length, so we would say that this one is a parallelogram. So this four-sided shape is a parallelogram. Okay, one more example. -3, -2, 4, -2. We have -1, 2, and 2, 2. So connecting the lines, the sides for this four-sided shape. So this one, there's no right angles. I can see I have one set of parallel lines. This one, if you're thinking trapezoid, trapezoid is correct for this one. So we can, if you have the list of four-sided shapes, you can use that to figure out which four-sided polygraph is being graphed. So now that we know what the different four-sided shapes are, we can use those shapes and know with the rules of those. So where a rectangle has four right angles, but one length is longer than the other. Or, for example, parallelograms, all sides are parallel, but not all the same length. We can use those rules to help us determine missing vertex points. So looking at an example, I have the parallelogram, so it's telling us it's a parallelogram. ABCD has vertices at the coordinates -3, 4, 5, 4, -6, 1, and point D. So if we plot these points, -3, 4, and then the point 5, 4, and then the point -6, 1, we can see that we have the beginnings of a shape of our parallelogram. So in order for this to be a parallelogram, we have to have two opposite sets of parallel lines. So one way to figure out where the missing vertex is, if you count the distance from this point to this point, so 1, 2, 3, and then 1, 2, 3, it's the distance of 3 over 3 away. So from this point, down 1, 2, 3, 1, 2, 3, our missing vertex should be here, and that would give us our parallelogram. We can see that this is our parallelogram. The two lengths here would be the same. 1, 2, 3, 4, 5, 6, 7, 8. Same as this one. 1, 2, 3, 4, 5, 6, 7, 8. So there's our parallelogram. Let's try another example. This one is a rectangle. So the rectangle ABCD has vertices at the coordinates 0, 2, 1, 3, 3, 1, and point D. So if we plot these points, so 0, 2, 1, 3, 3, 1, we can start to see the shape of our four-sided polygon here. So we know that it's a rectangle, so we know that we're needing to create right angles. We know we need to create right angles, but where would our missing point be? So looking at this, one way we could figure out what the slope of this line is. So rise over run. So 1, 2, 1, 2, the slope is 1. So this point should also have a slope of 1. This side should have a slope of 1 to get to our next point. So to the right 1, down 1. To the right 1, down 1. here's our missing point. That would complete our rectangle. So if we've got this, if we know how to use the slope, I knew how to figure out the slope of this line here. This slope should match that slope because they're parallel lines, so they should have the same slope. So we were able to count out the slope for this one to get to our final point. So just to review, you can determine what four-sided polygon is graphed by remembering the rules of slope for parallel and perpendicular lines. Parallel lines have the same slope. Perpendicular lines have negative reciprocals for the slope. And then the second step for finding the missing vertex of a polygon, you can plot the points and know what polygon is graphed, and then use the rules of those polygons to determine where the missing point is. Keep in mind, you can use the rules you know about slopes, perpendicular slopes. So if you're trying to find this line, know that it's a negative reciprocal slope of this one. And just like we did on that other example with the diagonal lines, you can figure out the slope of this line by using the rise over the run and compare it to the slope of this line. They should be the same.